Hello, friends. So, today we are going to take up problems related to engineering services examination, and this is based on basic properties of the soil mass. And this is the question in conventional examination 2017 of engineering services examination. The question is like this. A soil has a void ratio of 0.7, degree of saturation 50%, and a specific gravity of soil solids GS equal to 2.7. Find the water content 1, bulk density or total density, and the dry density. By how much can the water content be increased without changing gamma D? So this was asked in Engineering Services Examination 2017. Let's attempt this and find out the solution based on the basic properties of the soil mass. So the basic properties of the soil properties are void ratio, which is given over here as 0.70, and degree of saturation SR is given as 50%, that is 0.5, and the value of a specific gravity of soil solids GS equal to 2.7. So we have to find out first the water content. So water content, the symbol as you know is W, and based on this you can find it out very easily. So E into SR equal to W into G. This is the basic relationship between void ratio, degree of saturation, and the moisture content, and a specific gravity of soil solids GS. So this is the relation ESR equal to W into G. Now the void ratio in this problem is given to you as 0.7. So we can, on substitution, it will be 0.7, and degree of saturation is only 50%, so it should be 0.5, must be equal to the water content uh, W into the specific gravity is given as 2.7, so into 2.7. Therefore, the water content can be calculated as 0.7 into 0.5 divided by 2.7. So if you calculate this, we can get the answer. This comes out to be 0.1296, that is 12.96%. This is the value of water content. So first part, this part water content, we have found it out. The second part of this problem is find out bulk density or total density. So bulk density or total density is called gamma T, and also you will have to find out the dry density. So gamma T is going to be G plus E into SR into gamma W divided by 1 plus E. This you know it from three-phase diagram, the relationship between a specific gravity, degree of saturation, and gamma T. So this is the relationship that total unit weight or bulk density gamma T equal to G plus ESR gamma W upon 1 plus E. So quite simple because things are all given. So on substitution of all these things, here the void ratio you should be able to calculate it. So void ratio is also already given. So let's substitute. So G is 2.7, E is already given as zero point 0.7, and degree of saturation is 50%, that is 0.5. Gamma W is well known, 9.81 kilonewton per cubic meter divided by 1 plus E will become 1.7. So only by simplifying, I can calculate the value of gamma T. So let's calculate it. So 2.7 plus 0.7 into 0.5 multiplied by 9.81 divided by 1.7 gives me 17.6 kilonewton per cubic meter. So the second part, the answer is gamma T. So this is the first part. This is the second part. Gamma T we have calculated. And now the third part is dry density. So calculate dry density. So the dry unit weight gamma D is gamma T divided by 1 plus moisture content, or we can use it G gamma W divided by 1 plus C. Either way you can calculate. So gamma T is already known to us, and moisture content we have already calculated as 12.96%. So here if you calculate gamma T is 17.6 divided by 1.1296 divided by 1.1296 gives you 15.58 kilonewton per cubic meter. This is the answer of dry density. Or if you substitute here by using this formula, let's calculate it. 2.7 into 9.81 divided by 1.7, you get the same answer from here, 15.58. So either way you can calculate the value of dry unit weight gamma D. Now the question is, how much can the water content be increased? So you want to increase the water content uh, without changing gamma D. So how much you can increase the moisture content? You can make it fully saturated. And if you make the sample fully saturated, it is partly saturated because the degree of saturation is only 50% here. Now, if you want to make it fully saturated, how much can the water content be increased? So, the maximum water content, maximum water content that can be increased equal to W max. This will be corresponding to fully saturated soil mass or soil element. So when it is fully saturated, that is degree of saturation equal to 100%, that is 1. So without changing gamma D. Now what is gamma D? Gamma D is given as Z gamma W upon 1 plus E. You are not going to change it. It remains same. G, you are not going to change it for the given soil mass. The soil solids, this specific gravity for soil solids remains same. Gamma W doesn't change. So E is also going to be constant. Therefore, without changing gamma D, therefore, no change in gamma D implies E is constant. No change in value of E, and the void ratio remains. Therefore, E is going to be 0.7, no change. Now, E into SR, therefore, E into SR equal to W max into G for fully saturated soil mass. So now you can find out the maximum increase in water content, W max. So therefore, E remains 0.7, degree of saturation for fully saturated is 1, equal to W max, and G is not going to change, that is, it remains at 2.7. Therefore, W max equal to 0.7 divided by 2.7. So 0.7 divided by 2.7 is equal to 0.2592. That is 25.92%. So what is the, by how much the water content is to be increased? The maximum water content that can be increased is going to be difference of this and the moisture content which we have already calculated, which is 12 point something, and therefore you can easily uh, uh, calculate it. What it was, E into SR, so zero point 0.7 into 50%, zero point 0.5 divided by 2.7 gives you 12.96. So originally it was W was 12.96%. So the difference of these two will give you the amount by which we have to increase the water content. So the water content that needs to be increased is going to be 12.92% minus 12.96%. So the difference can be found out. This is equal to 12.95, 12.95%. So we are going to increase the water content by 12.95% so that the sample becomes fully saturated. That is the maximum. Uh, that is the maximum moisture content or water content that can be increased. So, a very intelligent way you can solve this problem of engineering services examination. So, friends, I hope you have understood this problem in totality. And if you have any question in your comments, you can always give your feedback and comments. And if you have any particular doubt, that also you can write in your comments box so that I can explain those points to the best of my ability, and I will try to make the points crystal clear. The next problem on basic soil properties, I will take it of 2019 problem. So another problem I will be taking it, uh, ESE 2019 problem. So ESE 2019. The problem is like this: liquid limit and plastic limits test. Liquid limit and plastic limit tests were carried out on a soil sample as per Indian standard method. The values were 60% and 36% respectively for liquid limit and plastic limit. What is the type of soil soil based on the above test data. As per Indian standard soil classification system or Indian standard classification system. Justify your answer. There is the problem, the solution, we can see it. LL is given to you in this problem as 60%. So given that liquid limit 60%, plastic limit 36%. Now, if you are going for IS soil classification system, you can always have the plasticity chart. The plasticity chart gives you the plasticity index IP in percent on the y-axis. On the x-axis, it is the liquid limit in percent. And as you know, there is a line, straight line, which is called A line. Its equation is 0.73 liquid limit minus 20. This is the equation of the A line. So this is 20. And here 35 liquid limit, then liquid limit is going to be 50. So like this. Now, you know the given from the given data, you have carried out the test. So the tests have been carried out in the laboratory. Therefore, from the test data, the plasticity index of the soil is given to you as a liquid limit minus plastic limit. So it is going to be 60 minus 36. So it is going to be 24% IP of the soil mass. This is IP of the soil mass. Now IP of the A line, the equation is given to you. IP of A line is given by IP of A line as 0.73. Now, what is the liquid limit? It is 60%. So, substitute LL equal to 60 minus 20, because this is 20. So, it becomes 40 into 0.73. So, 40 into 0.73 is 29.2. So this comes out to be 29.2%. So IP of A line, now you compare IP of soil and IP of A line. So IP of soil is only 24%, whereas it is 29.2%. Therefore, IP of A line is greater than IP plasticity index of the soil, which is only 24%. That means the IP of soil is below the A line. Therefore, uh, point will lie at 60%. Let's say this is 60. So, IP is going to be 24%. This is going to be 24%. And IP of the A line at 60% is given to you as 29.2%. So your point is here below the A line. This point, let's say this point is P. So the point P therefore lies below A line, isn't it? And if it is below the A line and liquid limit more than 50%, it is either MH or OH. It is going to be silt with high plasticity, or it is going to be organic soil with high plasticity, because since liquid limit is greater than 50%, it is 60%, no? Therefore, high plasticity. High plasticity. So the symbol will be H. And because it is below the A line, therefore it is either M, that is silt, or O, that is organic soil. Therefore, if you combine, it is going to be, therefore, the classification as per Indian standard plasticity chart or IS soil classification system, the classification will be MH, silt with high plasticity, or it will be organic soil with high plasticity. So that is the answer. So we have justified our answer, and the classification is MH or OH. So the complete justification for your answer, and that you can always look into. And in the examination, you must draw this chart, make this point where your point lies, whether it is above the A line or below the. If it is above the A line, it is going to be clay with high plasticity. But because your point is IP is only 24%, whereas IP of A line is 29%. So your point is below the A line, and therefore it is going to be MH or OH. So next problem we will see, and that is of 2021. So next problem on soil properties itself, that is the basic soil properties, and that has been asked in engineering services examination of 2021. Very important questions are being asked. It's a very simple question. The Mass, a specific gravity, a specific gravity. You say a specific gravity of soil solids, or it could be mass specific gravity. Mass specific gravity, when you take the complete mass, and the normally the symbol for mass specific gravity, we call it G mass, G M. So the specific gravity, mass specific gravity of a fully saturated clay having a water content of 29% is 2.0. On oven drying, mass specific gravity drops to 1.60. Calculate a specific gravity of clay that is GS of soil solids. It means a specific gravity of clay assuming the void ratio to remain unchanged. Friends, you already know what is the difference between a specific gravity of soil solids and a mass specific gravity. So here, given is for fully saturated clay, given is the mass specific gravity, and the water content, corresponding water content is also given. So let us see the solution. So solution is going to be quite simple here. What is given? Data is already here mentioned, that moisture content or water content is 29%, and the mass specific gravity is this much. So we know that the mass specific gravity is given by the total unit weight divided by unit weight of water. So this is the total unit weight, and because it is completely fully saturated, this can be written as Gamma saturated divided by gamma. Now, what is the relationship between gamma saturated and gamma D? Moisture content is known to you. So, this can be written as gamma D, that is the dry unit weight, plus into 1 plus moisture content divided by gamma W. And gamma D, you know that gamma D is G gamma W, that is the specific gravity of soil solids, upon 1 plus E into 1 plus W divided by gamma W, because gamma D equal to G gamma W upon 1 plus E, where gamma W is the unit weight of water, G is the specific gravity of soil solids, E is the void ratio. So, in this form, when you write it, the gamma W in numerator and gamma W in denominator gets cancelled out. Therefore, on substitution, if you substitute the all data on substitution, let's say this is 1, on substitution, the values in 1, GM is 2, given data. Finally, you get G, which you have to find it out, and into 1 plus W. Now the moisture content is 0.29, so it becomes 1 plus 0.29, 29%, divided by, it is 1 plus E. So here the value is going to be 1 plus E, and soil is fully saturated. So we get of this form 2 equal to this divided by this. And for fully saturated soil, for fully saturated soil mass, the degree of saturation will be 100%. Therefore, E into SR must be equal to W, that is the moisture content, into G. So I can replace, therefore, E equal to WG. So I can write here, because the void ratio remains unchanged, so I can write, therefore, or 2 equal to G, which I want to find it out, into 1.29 divided by 1 plus WG. So if I further simplify, G into 1.29 divided by 1 plus 0.29 into G. So 2 equal to this much. So what is unknown is Z, or if you simplify it, or 2 plus 2 into 0.29 G equal to 1.29 G. So on simplification, I am going to get this value. So now you can calculate it and find it out. So on simplification, uh, 2 into 0.58. So, or 2 equal to 1.29 minus 0.58 G. So, 0.71. So, G equal to 2 divided by 0.7 ones. 2 divided by the 2.81. This is the answer. So here, calculate the specific gravity of clay, which is 2.81. When the void ratio remains constant, because gamma d doesn't change, so the void ratio has to be uh, same, and therefore we can find out the value of z, that comes out to be 2.816 to be precise. So approximately you can say 2.82816. So friends, in the next video I am going to solve lot of problems with all conceptually. I will explain how the things can be calculated so that in the examination you fare very well and you don't face any problem while appearing in engineering services examination. I hope you will be able to give me your good feedback, and I will be also encouraged to come up with more and more um, uh, this classical explanation of all the problems. Thank you very much.